Hi all. We can now discuss about the last portion of module 2, that is unguided transmission media. We had already discussed in last video, that is wireless propagation, also a guided transmission media. Actually, the guided transmission media is known as a physical path for the signal transmission. Here we can discuss about unguided transmission media. So common unguided transmission techniques are radio waves, microwaves, as well as infrared waves. So broadcast radio, microwave can be of two types: terrestrial microwave and satellite microwave. Also we have the third unguided transmission media, that is infrared transmission. It's actually used in some LAN applications. Okay, so here we can discuss about the unguided transmission media or wireless transmission media. There is no physical path for the transmission of signal. So there are of three types. What are they? They are radio waves, infrared waves, and microwaves. So what are the general ranges of frequencies for our wireless transmissions? If we have a range of frequencies in between 2 GHz and 40 GHz, they are known as microwave frequencies, and it's a highly directional beams, and it's suitable for point-to-point transmission. Also it's used for the satellite communication. Okay, so the first category of wireless transmission or the unguided transmission medium is microwave frequencies. So the range of frequencies in between 2 GHz and 40 GHz. So mainly it is used for the point-to-point communication. Also it's used for the satellite communications. Okay. Next we have a range of frequency that is between 30 MHz to 1 GHz. What it is known as radio frequencies. And what are its applications? It's an omnidirectional applications are there. Next, the high frequency range, that is infrared frequency, and it is also used for the local point-to-point communication. Also it's used for the multi-point communications, but within a particular room or in a building. Okay, so infrared frequencies, they are mainly used within a particular room or a particular building. So it's actually used for the short range telecommunications. Okay, so there are three mechanisms for the unguided transmission media. Which are they? They are broadcast radio waves, microwaves. Microwaves are of two types: terrestrial microwave and satellite microwave. Also we have a infrared transmission media. So next we have a antenna. What do you mean by antenna? Actually it is an electrical conductor that's used for radiating some electromagnetic energy or for collecting some electromagnetic energy. So we have the transmission antenna as well as the reception antenna. We are using a transmission antenna. Here there is a conversion of an electrical energy into an electromagnetic energy. But in the case of a reception, here the antenna converting the electromagnetic energy back to electrical energy, radio frequency electrical energy. So actually the conversion is from electrical energy to electromagnetic energy, as well as from electromagnetic to electric signals. Okay, so actually that is the main purpose of antenna. Antenna is used for the signal transmission. It's an electrical conductor, or it radiates or collects some electromagnetic energy. So the same antenna we can be used in both, as well as a transmission antenna as well as a reception antenna. So these are all about antenna, and we have lots of types of antennas based on the radiation pattern, how the signals are radiated. Based on that we have many categories. One is an isotropic antenna, next one is a horn antenna, third one it's a parabolic antenna. So antenna can radiate the power in all directions, but it does not perform equally well in all directions. So based on the space coordinators, it can radiate energy in all directions. So first one, we have an isotropic antenna. So here the power is radiated in all directions equally. So this is the figure which shows the radiation pattern of an isotropic antenna. So actually here the radiation pattern follows some spherical radiation pattern, right? You can see in figure the radiation pattern of the isotropic antenna is something like a spherical manner. Okay. So first category of an antenna is an isotropic antenna. That means the power is radiated in all directions equally based on the space coordinates, right? So it follows a spherical radiation pattern. So this figure shows the isotropic antenna. Okay. Next we have a horn antenna. You can see in figure it's just like a horn or it's just like a gigantic scoop. Okay. Here the outgoing transmissions are broadcast up a stem and deflected outward in a series of narrow parallel beams. You can see in the figure. Also the received transmissions are collected by the scooped shape of the horn. Okay, and deflected down into the stem. So this is a type of antenna which is known as a horn antenna. It's just like a gigantic scoop. And what is the direction of reflection? It's just like a narrow parallel beam. Okay, also it's a unidirectional antenna. Isotropic antenna, it radiates power in all directions, so equally well, and its radiation pattern is a spherical radiation pattern. But in the case of horn antenna, it is a unidirectional radiation pattern is there, or it's a unidirectional antenna. It's something like a gigantic scoop or something like a horn-like structure. That's why it's otherwise known as a horn antenna. Okay. So second type of antenna is a horn antenna. Next we have a parabolic reflective antenna. Name itself shows that it's a structure of that antenna is something like a parabola, or it's a reflective antenna. Reflection is the main property that is handled within the parabolic reflective antenna. So it is mainly used in terrestrial microwave, also in satellite applications. So actually what is a parabola? It is a focus of, it is a locus of all points that is equidistant from a directrix as well as a focus. What is actually a directrix? It's a fixed line, right? What is actually a focus? It's a fixed point. So from directrix as well as from the focus, we have a collection of points that is equidistant from the directrix as well as a focus, that will form a parabola like structure. So its surface is actually known as paraboloid. Okay. So this is a representation of a directrix as well as a focus. Focus is a fixed point and directrix is a fixed line. Okay. So in the reflective antenna, like parabolic reflective antenna, if the source of the electromagnetic energy is placed at the focus of the paraboloid, and if the paraboloid is a reflecting surface, then the wave will bounce back. So electromagnetic energy source is at the point focus, right? And the paraboloid surface is a reflecting one. Then if we start transmitting the signal from the focus to the surface, it will bounce back because the surface is reflecting in nature. Okay. On reception side, if the incoming waves are parallel to the axis of the reflecting paraboloid, so definitely the resulting signal will be concentrated at the focus, right? On the transmission, starting the transmission from the focus to the surface, and if the surface is a reflecting one, it will be bounced back. That is the nature of the parabolic reflective antenna. And if it is a reception, then it will accept some waves that are parallel to the axis of reflecting paraboloid. Definitely the resulting signal will be focused on the focus point, or it will be concentrated on the focus. That is the main property of the reflective parabolic antenna. You can see in figure. First one is actually a transmission. Okay. You are starting from the focus. It will pointing to reflecting surface. Definitely it will bounce back. Right. Next one, it is a reception structure. That is, if we are collecting the narrow parallel beams on the reflecting surface, definitely it will be concentrated on the focus. Okay, so these are all about parabolic reflective antenna. Then, so we have already studied what is actually unguided media. It's a wireless transmission. And what are the types? Infrared waves, broadcast radio waves, as well as microwaves. And microwaves can be of two types, that is terrestrial microwave and satellite microwave. Next, we studied what you mean by antenna. What are the types of antenna? Actually, antenna is an electrical conductor. Why it is used? For transmitting and receiving signals in the form of electromagnetic energy. So, in the case of transmission, there is a conversion from the electrical energy to electromagnetic energy. And on the receptions, we have another conversion, that is from electromagnetic energy to electrical energy. Also, we have three main types of antenna that you have to study in this syllabus. That is, first one is an isotropic antenna. It is actually the radiation pattern is a spherical radiation pattern because it is radiating the power in all direction equally well. That is why it is known as a isotropic antenna. Next, we have a horn antenna. It's just like a scoop or a horn-like structure. Also, it's a unidirectional antenna. And we have a parabolic reflective antenna. And the structure of the surface is a parabola. Also, the surface is reflecting one. So it is actually based on the directrix, a fixed line and a focus. We can concentrate all the signals into a particular point, that is the focus, or it's a fixed point. So by using all the three types of antenna, we can study wireless transmission. Next, we can have an antenna gain. How to calculate the antenna gain? What do you mean by actually antenna gain? It's a measure of directionality of antenna. Also, it is expressed in decibels. And how it is calculated? So, it's actually based on the effective area of antenna. Also, it relates to some size and shape of the antenna. And the effective area of an ideal isotropic antenna is lambda square by 4 with a power gain of 1. And the effective area of parabolic antenna with a phase area of 0.56 A is 0.56 A with a power gain of 7A by lambda square. So antenna gain, it's actually the measure of directionality of a antenna, and it is measured in decibel. How it is calculated for the isotropic antenna and for the parabolic antenna. For the isotropic antenna, the power gain is 1, and for the parabolic reflective antenna, it is 7A by lambda square. What is actually A? A is the effective area of antenna. So this antenna gain is which is directly proportional, or which is based on the effective area of the antenna, as well as it's related to its shape and size. Okay, so here G can be calculated as 4 pi effective area divided by lambda square, or it can be 4 pi f square by c square into A. G is the antenna gain, A is the effective area, F is the carrier frequency, C is the speed of the light, and capital A is the carrier wavelength. So you have a question for workout. You just go through this question and find out the answer. Next, we have another transmission mechanism, that is microwave transmissions. We have already discussed that the microwave can be of two types. One is a terrestrial microwave and another one is a satellite microwave. So it's mainly used for the point-to-point transmission. Also, the range of frequency is between 2 GHz to 40 GHz. So the terrestrial microwave transmission, actually the microwave is transmitted between the two earth stations, or between two antennas within the earth. Okay, and in the case of satellite microwave transmission, actually the signal transmission is in between the earth station as well as the satellite. So that is the main difference between the terrestrial microwave as well as the satellite microwave. Okay, so second wireless transmission mechanism is a microwave transmission, are of two types, terrestrial and satellite. terrestrial in between the earth stations, and satellite in between the earth stations as well as satellite. So this is the figure that shows the terrestrial and satellite microwave communication. That is, we have at Earth a lot of Earth stations or antennas are there. In between the Earth stations, we have a transmission. Then that's known as a terrestrial one. But if it is in between the Earth station as well as satellite, they are known as satellite microwave transmission. So first one, we have a terrestrial microwave. Actually, it is used for the long range communication, also in voice and television transmission. Also, it supports some point to point links between buildings and land. Here, the microwave antennas are usually located at substantial heights above the ground level to extend the range between the antennas. Also, it has a higher frequency, higher potential data rate as well as a higher data rate. Okay, and it will follow some parabolic dish to focus a narrow beam onto the receiver antenna. Also, the typical size of the antenna is 3 mm in diameter. So the terrestrial microwave, first category, it's used for the long range telecommunication as well as in voice as well as in voice as well as in television transmission. Also, it's used for the point to point communication in buildings and land. It has a higher frequency, higher bandwidth and higher potential data rate. Okay. And the main sources of losses here in the case of terrestrial microwave are effects of rainfall, interference as well as the attenuation. And the attenuation loss can be calculated as it is equal to 10 log 4 pi d by lambda whole square, which is expressed in decibel. And what is actually d? D is the diameter of the antenna. And what is lambda? It is the signal wavelength. Okay. So the attenuation is the loss of energy, right? So attenuation loss can be expressed in 10 log 4 pi d lambda whole square, and which is expressed in dB. And other sources of losses are effects of rainfall and interference. This is the figure of terrestrial microwave. We have a lots of earth stations in earth. Between them, they have a signal transmission, that is by using the terrestrial microwave. Okay. Next, we have a satellite microwave. So it is used to link some ground-based microwave stations as well as the satellite. So here we can use a communication satellite as the microwave relay station. Also, we have two types of frequencies that we can use here. One is an uplink frequency and other one is a downlink frequency. And what is actually uplink frequency? So the satellite receives some transmission with a particular range of frequency, that is actually uplink. And the satellite that transmits some signals to the earth stations with a particular range of frequency, that is known as a downlink frequency. So satellite microwave, we have a communication or signal communication between the earth station as well as satellite, and with the help of two range of frequencies. One is uplink and another one is downlink. So this is the figure that shows the satellite microwave. So the applications, it's mainly used in television, long distance communication, private business network and global positioning, etc. So for effective satellite communications, we have a communication satellite, but it should be remain stationary with respect to the earth stations. So for remaining stationary, the satellite must have a period of rotation equal to that of Earth's period of rotation. That is for effective communication. Clear? For effective satellite communication, the communication satellite must be in a stationary position, or its period must be equal to the Earth's rotation period. So actually, this satellite microwave communication, which is used for point-to-point link mechanism, also it's used for broadcast link mechanism. You can see in the figure there are mainly three types of satellites. One is satellites, LEO satellites as well as MEO satellites. GEO satellites, its distances from Earth's surface is 22,300 miles. LEO satellites, it have a distance from Earth's surface is 325 to 1000 miles. And in the case of medium Earth orbiting satellites or MEO satellite, it is positioned at 6,000 to 10,000 miles away from the Earth's surface. Okay. So actually the satellite signal can only reach some part of the Earth. That area is actually known as footprint. So you can see in the figure, satellite microwave transmission can be used in point-to-point communication. You can see in the figure, from Earth station to satellite antenna, then satellite antenna to next Earth station. That is actually a point-to-point link, right? And in the next figure, you can see multiple receivers and transmitters are in the Earth surface. Also, there is a satellite antenna. We have some transmission as well as reception at the same time. It's something like a broadcasting mechanism. So it's also used for the satellite broadcast link. Okay. Next, we have a second communication mechanism, that is radio waves, right? So its a range of frequencies 3 kilohertz to 300 gigahertz. And these radio waves are omnidirectional in nature. Also, the sending and receiving antennas do not have to be aligned. Omnidirectional property has disadvantages too. Also, they are very much susceptible to interference by another antenna. Also, it can be propagated in a sky mode. Also, it can travel long distance. So, it's radio wave. It can be mainly used for the long distance communication or broadcasting, such as AM radio. But it can also penetrate the walls with low and medium frequencies. So mainly it is used inside a building. It cannot be used for the outside a building. That is the main disadvantages. Also, this radio waves band can be divided into number of subbands. So these are all the properties of a broadcast radio waves. Next, we have infrared waves. Actually, the infrared waves frequency range is in between 300 gigahertz to 400 terahertz. It's a long range frequency also, but it's used for the short range communication, not for the long range distance communication. Also, it cannot penetrate the wall, but we can be used in a remote control mechanism. We do not interfere with the use of the remote by our neighbors. So the infrared signals which are used for the short range communication, not for the long range communication. Also, it cannot penetrate the wall, and it is very infrared waves are less susceptible to interference. But if this infrared waves can be used outside the building, it is very much difficult because the sun rays contain some infrared waves that can interfere with the communication. Okay. So the main application for the infrared light or infrared signals are the TV remote control, IRDA port, etc. So these are all about the unguided transmission media. We have microwave transmission, radio wave transmission as well as infrared transmission. Thank you.